All right, guys. Are there any questions over any of the assignments before we get started? Any questions over the homework assignments? Now, what we're looking at today is solving radical equations.
Oh, I have a question for you.
Yes.
Why can't we talk about the ACT or what we did on the ACT today?
Because the ACT, as part of the guidelines, any test questions that are discussed outside of it are not allowed. There is a set bank of questions that they always pull from. So we're not allowed to talk about them or remove testing items from the testing facility. Yeah. I think out of the four, I think math is one of the harder ones, not so much just overall difficult. It's just the fact that you're jumping from one topic to the next, because it's going from pre-algebra stuff you did in middle school to algebra 2, then to geometry and algebra 1. It's just jumping so much. It takes a lot of time to get used to, let alone the fact you got 60 minutes to do it. So switching gears is some of the harder parts of that.
My science didn't have graphs. Oh, I guess I'm sorry. It's hard. Yeah, last year. Like the science, I'd be like, oh, I know that.
And a lot of the science, all except for 2 out of the 40 questions require, or all except for 2 do not require previous knowledge. There's only 2 questions on the science. You actually had to know something about it to answer the question. They throw a lot of big terms, confusing topics, or stuff at you just to see if that will confuse you. Because most of it, if you focus on what's it talking about, either student 1, student 2, student 3, graph 1, 2, 3, paragraph 1, 2, 3, or the specific terms, are they looking for moles per whatever, the units, and finding those in the charts or in the paragraphs, and looking at that there.
Here's something that Reed told me. I was like, what'd you get last time? He said 30. I was like, that's good. He said, it's not even good. I want like a 34. And I was like, what?
The higher you get, the more scholarships you get.
Right? That 30 is good.
30 is a very solid score.
But the dude was like, it's not good enough. Like,
but
he was upset with it.
I wouldn't say upset, but he has standards for himself that he wants to do better. Yeah. Because the likelihood that ACT being used for entrance exams for college may or may not be here in the next so many years, but they're still going to use it for scholarships, be able to get scholarships, because they need a way to be able to grade or see comparatively difficult how well you're doing, so they can compare one student to another to be able to award scholarships. Now, looking at this here, because again, that is the last time Call Court is going to make you guys take the ACT. You can still take it. You can take it up to 12 times total. I've not heard of anybody actually taking it 12 times, but it is a possibility. Okay? Now, what we're doing today is, once you get the hang of it and what we're doing, it's going to make sense. Most likely, we're not going to have to go through everything, single example problem. You're going to get the hang of it pretty quickly. Now, the theorem that we have here to start with is squaring each side of an equation. If 2 expressions are equal, then the squares are also equal. So if we have 2 things that are equal, if we square them, square both sides, they're still going to be equal. They're not going to change. One's not going to be more than the other. So with solving these here, I'm going to put together some steps that we have. 1 is there more than 1 radical? If no, then get it by itself, guys. Is there more than 1 radical? If no, there's not more than 1, get the radical by itself. Get it by itself. So looking at this here, is that really coffee grounds?
Yes, sir.
Okay. Now, looking at this equation here, is there one radical? Is there more than one? Well, no, there's only one. So what we want to do is get the radical by itself. Well, what's the first thing we can do to get the radical by itself? We can subtract 5 from both sides, because 5 minus 5 is 0, telling us the square root of x is 8. So we're almost done for this one here. So did we get the radical by itself?
Yeah.
Okay. Step 2. Put both sides to the nth power. Put both sides to the nth power. Now the main goal of this here is really to reduce this radical. What power can I put a square root to get the square root to simplify out? Yeah. No, because if we square a square root, the square root and square would cancel out, leaving us with x by itself. It wouldn't be like 64. It is 64. Yeah. Now, really, those are the main steps. Now, is there still a radical? If so, repeat steps exactly 1 and 2. And the only other step besides part B, which we will come back to in a minute, is solve. Or we can say for step 3, if there is still a radical, repeat steps 1 and 2. And the last step is to solve. Now, step 3 will not come into play today. We won't talk about step 3 today. I want to list it so that you've seen it, and kind of it is a step, but we're not going to encounter a problem that would use it today. Well, let's look at the next one and see. Okay. Let's look at this here. So first step, is there more than one radical? No, we still just have the one, yes? If no, get it by itself. So how can we get the radical by itself? So we can add the square root of x, or we can subtract 3. So we can subtract 3. And if we subtract 3 from both sides, 3 minus 3 is indeed 0. And that tells us that negative square root of x is equal to negative 3. Is the radical by itself? So what do we need to do to get it by itself? So we have a negative, yes? We can by negative 1. Or we can multiply by negative 1. We really want to get the radical to be completely by itself. Nothing multiplied in front of it, nothing added to it, nothing subtracted from it, nothing being divided. We want it completely by itself. Negative 3 divided by negative 1 is 3. Now is it completely by itself? Okay? So we can put both sides to the nth power. In our case here, what is the nth power? 2. So we can put both sides to the second power. Does the square root and square will cancel, telling us x is equal to 9. Now, when we square both sides, we do not add a plus or minus because we're simplifying the square root. We don't have the plus or minus. If we put the square root or an even root of both sides, we need the plus or minus because we're talking about the square root of x. So we said it's 9. Well, the square root of 9, if we wrote it all the way out, same as the square root of 3 squared, which is 3. We know the square root of 9 is 3, yes? Now, if we had added the plus or minus, we would have also said that x that would be negative 9. Well, just like before, the square root of 9 is 3. But that negative comes out as I. This is part of the reason we can't have the plus or minus. If we take a square root, an even root of both sides, we do add it. Because we're starting off saying that x squared is 9. A number times itself is 9. Well, 3 and negative 3 would work for that there. Here, we're trying to see what number timed itself was that. There's only one case. Just 9. Questions on this here? Yeah, because we only have one radical. It is by itself. So we can put both sides to the second power, telling us x is. That's it. That is it. For most of these here to start with, yes. Are there any questions on these here so far? So again, we would add 7, square it, we're done. So I feel, because I put those in just in case we needed to see more, I feel like we feel comfortable with these here, so there's not a whole lot of reason to do extras. Now, looking at this here, 4 times the square root of x plus 2 plus 3 is 19. Well, is there more than one radical? Well, no. If no, get it by itself. So what's the first thing we can do? Yeah, I would always deal with addition or subtraction first. So we can subtract 3 from both sides. Telling us 4 times the square root of x plus 2 is equal to 16. Is the radical by itself? No. What do we need to do? Both sides by 4. Because on the left-hand side, 4 divided by 4 is going to be 1. Cancels out, leaving us square root of x plus 2 is equal to 4. Is the radical by itself? Yeah. I mean, we do have the x plus 2, but the x plus 2, all of that is contained inside the radical. So the radical itself is by itself. I'm not too worried about the x plus 2 at this point. So now we put both sides to the nth power. So in that case, it is 2. At this point here, square root and square would cancel. Leaving us with x plus 2 is equal to 4 squared is 16, yes? And that's our answer, yes? Is x by itself? No. We don't have to divide it, but we just have to minus 2. No, yeah. Because again, step 3, which is not going to come in today, there's no radicals left. But our last step is to just solve minus 2, telling us x is 14. Now, I don't know if you've noticed so far, on some of the instructions it does say to check your answer, because there are some extraneous solutions, some restrictions. Because we know already for us to have a real solution, the number inside the radical, we can't have a negative. We can't have a value of x that will cause what's inside the radical to be negative. We also know that, well, the square root of a number can't be negative. It just doesn't work because we dealt with that when we looked at, say, x squared equals -1. It doesn't work. So if we want to check this, we can say 4 times square root of 14 plus 2 plus 3 is equal to 19. And especially on the test, these are going to be some easy points to pick up. If it says to check it, this is the first part. We plug the value back in. At this point, I can grab the calculator, say 4 square root of 14 plus 2 plus 3 is 19. I just plugged it back in with the number we found in place of x. So it says 19 is equal to 19. It does check out. That's it. Questions on this here? Let's look at one more of these here, and then we'll move on to the next type, because I feel like we feel comfortable with these. Yes.
Yeah. All right. So, rewrite it.
Yeah, we can rewrite it. Plus 5.
That's a little too far.
So tap the eraser. Yep. Yeah. If there you go.
There you go.
You can say -1. So if you touch with the other end, it'll write.
Oh, okay.
Yeah. Tap the color. Other color. Yeah.
Guys, click. I don't know.
Right there.
There we go.
So click the colors. Yep. Yep. And then select your color. Yeah. Equals.
11.
Yes.
All right. There we go. So what you're gonna do first?
Add 1.
Leaving us with
3 plus 5.
equals
12. Yes.
Then what we're gonna do? 5 by 5.
Divide both sides by 3.
And then 12 divided by 3 is 4, right?
Yep.
There you go. Okay.
So we have square root
So,
x plus 5 equals 4. Then we square. Yep. 2.
Wait, what is that equal -1? 5 times 2 or 4 times 16? How does that work?
16. 4 squared 16.
16 minus 5. Yep, minus 5 on both sides. 5 x
Equals 11. Yep. That's it. Yeah. That's it. Questions on this here? Okay.
Wait, can I have a turn on the next one?
So,
Oh, dang, I thought this one right here was 5.
so I think we get a hang of this. Yes? This is where B comes in. Now, go back to our steps. So, looking back at the steps, and you did good. Is there more than one radical? Well, this time, yes, there is. So the second part of this is, if so, even them out. Because if there's more than one, we want to even them out. So if so, even them out. Now, what I mean by that is, for this here, we have how many radicals? How many square roots? 2. So when we even them out, we want 1 on either side of the equal sign. We want to have them even number. Now, if there had been 3, 2 and 1, or 1 and 2. We just want to have 2 on one side, 1 on the other. We don't want all 3 on the same side. If we had, say, 4, we would want 2 and 2. We want to try to keep them even as possible. Now, for the most part, at this level, we won't deal with 3 radicals. Even in most of the college algebra and above, we don't really deal with 3. 4 is not really heard of unless you get higher and higher, or kind of up and up. Now, for the most part, it's not too much difficult or more hard difficult. It's just our step 3 starts coming into play, because we end up not being able to reduce it or simplify it in just one main step. Now, for us here, we're not talking about getting it by itself anymore. Because if it's by itself, we're talking about 1. If there's more than one even amount, do we have them evened out? Okay. So I'm just going to rewrite it so I have a little more space. Now we can go to step 2, which is put both sides to the nth power. Now, because we only have that radical on both sides, the radical and the square will cancel out. So 2x minus 1, 2x minus 1 is equal to, we don't have any radicals left, so we just need to solve. Yeah, no, we can do that. Because I could have started off with, as we do here, subtracting 2x. We could have started off with subtracting x from both sides. We could have added 1 to both sides, subtracted 4. We just need to pick one of those to do. Because here 2x minus 2x is 0, leaving us with negative 1. X minus 2x is plus 4. Then we would indeed subtract 4, telling us negative x is equal to negative 5. So what would x be? So if negative x is negative 5, positive x should be positive 5. Or we can say we divide both sides by, telling us x is 5. And again, we could check this to make sure, saying, plugging it back in, square root of 2 times 5 minus 1 is equal to the square root of 5 plus 4. And for this here, I'd plug it in a calculator. Second square root of 2 times 5 minus 1. So both sides are 3. They are equal, so it works. Questions on this here? So, exactly. We already have them evened out, so we can minus x from both sides, telling us 3x. Mm-hmm. Yeah. It's just that we would have had negative 3x on the right-hand side instead of positive 3x on the left. That's it. Questions on this here? Oh, no. So they're on the same side. They're on the same side. So there is more than one radical. If so, even them out. So we need to get one on the other side, yes? Because the square root of 4x minus 7 is just a term, yes? Since it's negative, I can add it to itself. So negative square root of 4x minus 7 plus 4x minus 7 does cancel out. if I add it to one side, I have to add it to the other, just telling us that the square root of yes. Yes. So subtract 3x from both sides. Add 7. X equals 8. Mhm. Questions on any of this here? It's the exact same thing. Yeah.
Do the same thing, wouldn't you? Exactly the same.
Yes. So we have more than one radical. Did we have them evened out?
Yes.
Yes. Okay. So put both sides to the nth power, which is 2. Yep. So n is equal to 5n minus 1.
Wait, no, add one on both sides. Yeah.
Well,
Okay.
let's look, because we can add 1. Is n on both sides?
Oh, yes. Add 5.
So we can move the 5 in and get them all together, yes? Yeah, so we can subtract 5 in from both sides.
So it's on both sides we can do that?
I mean, we could have started with plus 1. Yeah. Now, the reason I would do that is because if I add 1, the left-hand side is now what? N plus 1 is equal to 5n. So the numbers without variables are already by themselves. Let's go on and get the variables by themselves.
N minus 5n would be
Negative 4n. Because we normally do try to avoid having a negative variable, but here it's going to be easier to go there. Then we can divide both sides by negative 4. N equals 1/4. As the negative and negative make a positive, and 1 doesn't divide by 4 evenly, so we get 1/4.
My turn? Is the next one the same? Oh, gosh.
Hey, it's just like you should do the first step. There's one right.
So, right. So let's work through this here, because this time we don't have a square root, we have a cube root, yes? So, let's see if the steps, this change affects the steps. Is there more than one radical? No. Get it by itself.
So would I have to like subtract it?
Is the radical by itself?
Yes.
Yeah, okay, so we can just rewrite it so we have a little more space. Now, probably at the start, when we wrote the steps out to begin with, it seemed a little odd that I said step number 2 is put both sides to the nth power instead of just saying put both sides to the second power, square both sides.
So it would be 3.
So we would put both sides to the third power, because saying the nth power lets us be able to do any radical, no matter what it is.
So this is gone too, man.
Mhm.
So it's 5x minus 2.
So the radical is gone.
What is 12?
So Roy, you don't need the radical.
Oh,
The radical
that's right.
Yeah.
Yeah. Oh, no, that's 12 times 12 times 12.
Because 12 squared is,
Well,
so
more than 1.
Roy, if you see at the bottom next to the Google Chrome,
That one?
the little, yep, either one of those, so we can say 5, or not 5, sorry, 12. And then we use 2 to the third, so our little caret key, the one above the division,
That one?
3. Enter. 1,728. 1,728. Then what would we do next?
Plus 2.
We'd solve, we'd add 2. Which tells us
5x equals 1/7.
Then divide by 5.
yep, divide by 5. Will this divide evenly?
Probably not.
No.
Well, it ends in a what?
Oh, it ends in 2.
Oh, yeah, so yeah.
So it should divide by 5.
So then that would be x equals
So you can do that one. Yep. 346. 346. That's it.
I always wanted to circle it up here. I was like, I can say
So having a cubed root, did that change anything? No, it's still the exact same process, except instead of squaring both sides, we cube it. Questions on any of this here? Because the next two are the exact.
same thing. Wait, go back. What do you want to do one real quick? All right.
One radical. So,
We would.
get it by itself.
So they wait.
So we would.
So you would cube it.
Well, almost. Because is it by itself? We have the 4, yes?
Yeah.
So we would need to.
Subtract.
Add 4.
But yeah, add 4. That's what
Mhm.
they yeah. So we write that. It's fine.
Yep. So the cubed root of y is 5.
And then you cube it.
Now we would cube it.
And then
Y is,
That equals
so
120.
y equals
I believe so.
125.
And we could use the calculator down there at the bottom if we want. Either one of those two. Try one more time. So 5.
So both calculators do the same, or does
Yeah.
one add more stuff to it?
The other one has graphing
Oh,
and some other features like that.
it's like those.
So y is 125, and that's it.
All right, back to next. Oh, you really like the real? Yeah.
So
There we go. Hey, we're right at Vegas now, right? Good.
So Logan, pause 1 second. I'll let you do that here in a second. Let's get.
Oh yeah, let me circle those real quick.
So this is the homework assignment here. So guys, I would go on and copy that down. It is in Google Classroom. 3 through 7. Odd. Odd. 7.